Hello everybody, in this video we'll be solving a few problems that you can expect in your quizzes, midterm and even in your finals. But before getting into the problems, let's just recap a few things that we learned in the previous videos. We learned about the detailed functionalities of 7 different layers of the OSI model. So we know what the application layer does, what the presentation layer does, what the session layer does, what transport, network, and data link layers do, and so on. So we kind of have a basic idea that when the data is being sent from the sender to the receiver, on the sender side, the data passes through all the 7 layers, and when the data reaches the receiver, once again it goes through all the 7 different layers. Additionally, we looked at what the data units in each of these layers are called. So when the data is being passed down from application, presentation, and session layer, data is still called data. But when this data goes to transport layer and transport layer segments the data, each of these pieces is called a segment. All right, so the transport layer is responsible for breaking the data down to tiny pieces or tiny chunks, and each of these pieces is called a segment. And one other thing that the transport layer does is it adds port numbers, right? So port numbers, I'll be getting into what port numbers are in just a bit. So port numbers are nothing but application identifiers, a number that would identify which application the data is belonging to or the segment is belonging to. Then the segment from transport layer gets passed down to the network layer, and in the network layer what you have is a packet, and a packet has embedded in it the segment. Alright, so network layer would add some data to the segment and the resultant unit would be called a packet. Alright, so a packet would have the port number and additionally some network layer information, which one of the things that are added to the packet is an IP address, and I will be getting into IP address in just a minute. But for now, just know that a packet would have port numbers that a segment has, and additionally it would have IP address. Okay, and of course some other header information as well. And then when this packet gets sent down to the data link layer, once again the data link layer would add some information or data to the packet, and the resultant unit would be called a frame, and a frame has encapsulated within it the packet and the segment. So a frame would have port number, IP addresses, and also information added by the data link layer, MAC address being one of the information that's being added. All right, so we need to keep this in mind when we're doing the problem. So remember that a frame would have port number, IP addresses, and also MAC addresses that's being added by the data link layer. All right. We have already learned about addressing. So every device in the network has 3 different types of addresses that it uses. First of all, it uses port addresses to identify the applications running within it. So let's say you're using a computer and you're using mail on one hand, and also you're using let's say your browser to browse a web page. All right, so the email service that you're using, that itself is an application, and you're also browsing a web page, that is also another application. Now two of them would be having to different application numbers. So let's say the email application has a port number of 110, and the application where you're running, let's say your browser like Chrome, running the web page would have a port number of 80, right? So port numbers are nothing but your application identifier. Now it's necessary for us to identify these applications because when you're sending out data, you need to be able to identify which application data it actually is. Okay, so it's just a way to mark where the data is coming from. Which application does the data belong to? Is it from your email, or is it from a web page you're browsing, and so on. Okay, and then you have IP addresses. Now every device in the network has something called an IP address. It is to identify your device in the network uniquely. All right, so let's say you have a wireless router and you connected a tab, two of your computers, and a printer with this a router. All right, so each of these devices will have a separate IP address. All right, so let's say this computer over here has an IP of 192.168.1.5, then this one would have something different. So it could have 192.168.1.6, and this one has 1.100. All right, so it is to identify each of these devices uniquely within the network. Okay, and then you have something called a MAC address, and MAC address is just the address of the physical interface that each of the devices use. So when you set up your computer, if you have noticed, you have something like a network interface card, and this one has a MAC address. Okay, so each of the network interface card, Wi-Fi cards, these have a burned in address, and this one's the MAC address that kind of tells you which physical interface exactly the data is going to be coming and going from. One other little concept that we need to keep in mind is hop-to-hop delivery. Now hop-to-hop delivery is carried out by the data link layer. Okay, so how this hop-to-hop delivery exactly happens is, hang on, let me get the laser pointer. Okay, so suppose device A over here is trying to send some data to device F. Okay, so device A and F are connected by some intermediary device. Now remember guys, this is the logo for a router, okay? And since some intermediary device is connecting the devices and they are not directly connected to each other, in order to send the data is going to be sent through some hops or jumps. Okay, so at first what we need to look at is what's the path that's going to be chosen in order for the data to go from A to F. So this is going to basically be the path, right? Because there are no other paths in this particular scenario. Okay, so the data from and system A is going to go through router B and E to reach F. Okay, so how that's going to happen is at first the data is going to go from A to B, and this is going to be your very first hop-to-hop delivery, and then the data is going to go from B to E, and that's going to be your second hop-to-hop delivery, and then the data is going to go from E to F, and this is going to be your third hop-to-hop delivery. So when the data is being sent from A to F, it's going to be sending the data through these hops or jumps, okay? And this is going to be done by data link layer with the help of MAC addresses. Let's look at a few more things. So suppose you are given this scenario and you want to identify the hops or jumps that's going to be taken while the sender is trying to send some data to the receiver. Now, suppose the sender is PC1 and the receiver is PC2. Now, this is going to be very simple because PC1 is just going to be sending some data to PC4 directly, all right, just in one jump because they are in the same network, okay? So how do we exactly identify the networks? Now remember guys that every interface of the router is a separate network, okay? So look at router 5 and you see this interface or port. This entire thing is going to be a network, okay? So this is a network itself, all right? And you see this interface over here, this is going to be another network, this is going to be another network, okay? So for router 4 over here, where I'm pointing at, this router has 3 different networks, this one, and this one, okay? So you see this interconnection among routers. These are also separate networks, although there are no devices added. For router 7, this is a network and this is a network, okay? So you have a network over here, and then you have a network over here, and also these interconnections are networks, all right? So suppose now the sender is PC1 and PC4 is the receiver. Now remember guys, sender is in this network and the receiver is in a separate network, right? So since they're in 2 different networks, there must be a router in the middle, at least one, or there can be even more routers, okay? Since they belong to separate networks. Now, the sender cannot reach the receiver just in one jump because they are not in the same network. They're in different networks, okay? So it has to send data through some hops or jumps, okay? So let's first try to identify the path that's going to be taken in order for the sender to send some data to the receiver. Okay, so look over here. If this sender wants to send some data to this receiver, at first the data has to go from here to this interface of the router, right? Because if it doesn't really have a way out of its network, okay? So the first hop is going to be from PC1 to router 5, okay? So I'm just gonna write it over here, and the data is going to go from PC1 to the router. Now, for the second jump, the data can go from router 5 to router 6, and it also can go from router 5 to router 4. Now, since there are 2 different ways, which path is the data going to take? Now, every router has something called a routing table. Okay, so I would like for you guys to just look up routing table on the internet. This is something you will be learning in computer networks. Okay, so a router basically have information regarding where to send the data. If you have an outgoing data for a separate network, the routing table will have information regarding this. Okay, so this router 5 already knows which way to send the data, all right? So for this particular scenario, we'll be choosing the shortest path, okay? So if you look at over here, the shortest path is going to be from here to here, okay? If you go through router 6, this is going to be a longer route. So these routing tables run multiple routing protocols. You can look into RIP, OSPF, and so on. All right, but for ease of understanding in this particular scenario, we're going to be choosing the shorter path. Okay, so remember, router has routing table that kind of has the information, destination information, okay, where to send the data when it is directed to particular destination, okay? So in this scenario, the next jump is going to be from router 5 to router 4, okay? So this is going to be your second hop-to-hop delivery, okay? So then the data is going to go from router 5 to router 4, okay? And then what's going to happen is the third jump is going to be from router 4 to router 7, right? So of course, router 4 has information regarding where to send the data in order to reach the receiver. Now, obviously, the router 4 could have chosen this path, but if you choose this path, you don't really reach the destination, right? So router 4 is going to be sending the data to router 7, right? And then router 7, of course, has information regarding where to send the data in order to reach the receiver. So router 4 is going to be sending data from, sorry, router 7 is going to be sending the data from router 7 to PC4. And this is going to be your fourth hop-to-hop delivery. So the one from router 4 to router 7 was your third hop-to-hop delivery. And from router 7 to router 4 is going, sorry, PC4 is going to be your fourth hop-to-hop delivery. And when that's done, the receiver has basically received the data. Okay, so these are going to be the hops taken when the data reaches from the sender to the receiver.